All right, hey there. So in this video, what we're going to be looking at is similar figures still. And you're going to notice that we're going to have dimensions instead of unknowns. You might remember that we previously looked at, we've got some dimensions over here, and then this is a 12, and we had an unknown right here, so we wanted to find it. And we did that by setting up a proportion. So the 10 would match up with the 12 in this image, and then the 8 would match up with the x. And then when we cross multiply and divide, we find the unknown. So that was one thing. And now we're looking at shapes that have all the dimensions labeled, and we're just trying to see whether or not they are similar. And if so, we should be able to prove it with some proportions. So the I can statement for today is I can determine if geometric figures are similar by writing proportions to express the relationships between those corresponding parts. Now that's a lot of words, and this is a fancy way of saying we're just going to write a proportion and match up the sides, and when we cross multiply, see if they're equal. So I'm going to highlight, like if I highlight this side blue, I think you guys would agree that it matches this side right here. And if I highlight this side yellow, that matches this side right here. So in the green box that I have here off to the side, we're going to try to prove whether or not these figures are similar. So one thing I'm going to do is I'm going to match blue to blue. So I'm going to say I'm going to match blue to blue. So I've got a 5 with a 10. And then I'm going to match yellow to yellow. So 8 with a 16. So this is a proportion, and we're going to see if this is true. Now immediately, what some of you might be recognizing is that the 5 doubled to be a 10, and the 8 does double to be a 16. So yes, these are similar figures. The 5 doubled to be a 10, the 8 doubled to be a 16. When we cross multiply, 5 times 16 is 80, and 8 times 10 is 80. So because we get both are 80, we have just proven that they're similar figures. Now another way we can prove it, that's why I've got kind of a larger box here, because I just wanted to show you guys one more way to prove this. I could say blue with yellow. So if I put the blue side with the yellow side, I'm just saying this height compared to the width. So blue to yellow, and now I'm going to compare blue to yellow. So the blue 10, and then the yellow 16. This is another proportion that will work. This shows right here the blue to blue, and this is right here doubling. So again, this works, and if we cross multiply, we still get a 5 times 16, which is 80, and 8 times 10 is also an 80. So we still get 80 on both sides, and yes, this proportion also proves that these are similar, okay? So are these two rectangles similar here? We're going to say yes, and we've just got a couple proportions here to prove it. All right, now here we were looking at rectangles. For the next example, we're going to be looking at triangles. And for this one, it tells us that they're similar. We have a similarity statement right here. It tells us that P matches up with D. So P, I'm just going to put right here in red. P is in the same spot as angle D. It tells us that Q is in the same spot as E. So Q is in the same spot as E. And then we see that R is in the same spot as F. So R goes with F. So we've got our corresponding angles. And we can use that to see here that this purple side with the 4 matches up with this purple side with the 10, okay? And then let me use a highlighter for the bottom part. I'll let this be a yellow 6, which matches up with this one. So we've got everything all matched up. Let me kind of clean that up and match that there and there. All right, so we've got our matching sides. And now let's take a look at this question. It asks which describes the relationship between the corresponding sides of the triangles. So we're trying to find which one of these shows purple to purple or yellow to yellow. So let's look at answer choice A. It says that side PQ is a 4, which that part is right. And then DE over here, see how DE it's saying is a 15? If PQ matches with DE, the 4 should be matching with the 10. So that right there does not line up, so we're not going to pick answer choice A. PQ to DE, purple to purple, but then again, that should be a 4 to a 10. So we're not going to pick. All right, for the next one, PR to DF. So PR is yellow and DF is yellow. So it's got yellow to yellow. But see how it flip-flop them? PR should be a 6 and then DF should be the 15. So this does not correctly show corresponding sides either. All right, let's look at C. So PR to DF. So PR is this 6 and DF is a 15. So PR is the 6, and it does match up with DF, but that should be a 15 right here. So we're not going to pick this one. Now, process of elimination, it looks like the last one's the only one left, but let's take a look at it. It's saying PQ to DE. So PQ does match up with DE. And this side is a 4 and this side is a 10. So this correctly shows the corresponding sides. The 4 matches the 10. Let's reread the question. It said, which describes the relationship between corresponding sides? So this is the right one that showed this matched up with this and the 4 and the 10. All right, now we're moving on to question 3. And for question 3, it says triangle cat is similar to triangle dog. So the first thing we can do is write our similarity statement. We've got CAT is similar to DOG. It goes on to ask us which side in triangle cat corresponds to side DG. Now DG over here would be this first letter and this last letter. So it should be the first letter and the last letter. And here we're looking for CT, so that's going to be this answer choice here. If it tells you what's similar, and you know spot or letter D and G are in the first spot and the last spot, then you care about first spot and last spot over here, which is the CT. Now I also want us to I'm going to just draw a triangle real quick, and you can just kind of sketch this with me. Let's say I just put triangle CAT down. So I'm going to let this be, let's put the C up here. We'll put A down here, and then this will be a T. Now it says that they're similar. So what I'm going to do is I'm just going to copy and paste it. This would be congruent. That would be congruent. So for similar, I'm just going to enlarge this one a little bit. It doesn't tell us if it's bigger or smaller. I just went with bigger. It doesn't really matter. But CAT matches up with DOG. And the side it wanted to know about was side DG, which is this side right here. So from D down to G. So that's right there. That's the C down to T. And that's how we pick that answer. To do a question like number 3, you really don't need shapes. But seeing the shapes really helps, I think, see those sides match up. Friendly reminder that if I care about DG, I care about this letter and this letter. So I care about first spot and last spot. So there we go. If I said which one lines up with DO, which is here in green, then that'd be the CA, because you can see DO and CA right there in green. So definitely use your similarity statement to help you out. The similarity statement is kind of like our new best friend. It really is a huge shortcut. All right, now let's flip over here. And we're looking at a parallelogram. And the question is, which parallelogram below is similar to this one? Okay. Now, the first thing I want to point out and remind you guys about is that with similar figures, the angles still stay the same. For example, if I just go back briefly to this, see how I made this triangle way bigger? But if I trace the angle in the smaller one, it's the same exact angle measure over here. So the angle sizes actually stay the same. So if this one appears a 110, it needs to stay the same as a 110. Now you guys can kind of see what I'm doing here. Even though my red line matches with all 4 of them, see how answer choices, this one would be A and like this one would be B right here. We're immediately going to not pick these right here because they're labeling that as a 120 and we know it should be labeled as a 110. Same thing again, we're looking for 70s here and here. So I see a 70 in both of these answers, and I see my 110 here and here. So that's why both of these are still fair game, okay? Now I got to look at the side lengths and see which one is proportional to this shape up here. Now there's lots of different proportions we've said that we can set up. Let me get my highlighter out. And you can kind of decide for yourself which one you think makes the most sense. But I'm just matching up corresponding sides right now. See how I've got yellow matching with the yellow and then green matching with the green? All right. So basically, if I go yellow to yellow, one thing I'm saying is that the 6.5 could turn into an 8, or the 6.5 could turn into the 13. We don't know which one yet. We don't know which one yet. Now I'm going to go green to green. So this side, the 12.5 matches up with a 14. And down here, the 12.5 matches up with a 25. We're just going to cross multiply and divide, and only one of these we're going to get the same answer, and that's how we know which one's proportional. Okay, so let me get my calculator real quick. Calculator. All right, so for the first one, we're just checking to see if this thing is proportional. If it's proportional, when we cross multiply, we should get the same answer. Okay, so I just matched yellow to yellow and green to green, and I'm checking to see if that means that this shape down here is proportional. Okay, that's all we're checking to see right now. So if I cross multiply and I do 6.5 times 14, all right, so 91. So if this multiplied equals 91, then we know it's similar. All right, so now I'm going to do a 12.5 times 8. Now I get 100 for that. So since I got 100 on this side when I multiplied here, and since I got a 91 when I cross multiplied these, that's not the same. So these side lengths are not proportional to this shape, so no, this one's not similar. Now for this one, some of you might have already caught it, that if you double 6.5, 6.5 times 2 is 13, and 12.5 times 2 is 25. So some of you might have caught that the yellow side doubled here, and the green side doubled here, which is enough to confirm that that's the similar figure. And just to make sure when we cross multiply, I'm going to do a 6.5 times a 25. And we get a 162.5, 162.5. And let's see if I get the same thing when I cross here. Yep, I get a 162.5. So again, when I cross multiplied this number, it was the same as this. We know that this, yes, is a proportion. And so therefore, this shape is proportional to this shape, which means it's similar. Okay? So real quick to recap, I knocked out some answer choices based on the angles, and then I just had to match up my sides. One other thing I'll point out is that if you care about yellow, yellow over green, you could have put the yellow over the green. Check this out. And then matched up down here, yellow over green, so the 13 over the 25. And that still works because that still shows times 2 here and times 2 here. And when we cross multiply, it's the same thing as getting cross multiplied. So yep, it would still work out that way. All right, a couple more problems down here. So for number 5, I just want to know which statement is true about the rectangles, okay? Now, friendly reminder that congruent means that they're equal. You're just talking about shapes. So I think we can agree these shapes are definitely not equal to each other, so definitely not going to pick the word congruent. Now, they could be similar. We just have to prove it, okay? Now, one way I can look at it is say, okay, well, this height right here, it looks like this height is half of this length. So then this height right here should be half of this length. And if this is a 5, technically that should be a 10 then. So no, these are not going to be similar. These are not similar figures. Right there, 2 doubles to this 4, so this 5, this should be an 8. Now another way I can prove it is to say, okay, well, this 4, this side doubled to be an 8 right here. So then this side should double right here, and this should be a 4. So again, I can say, no, these are not similar. It doesn't matter how I look at this. This is definitely not two similar figures, okay? Again, 2 to 5, the 2 matches with the 5, the 4 matches with the 8, and you guys can see right there that these would not be equal because 4 is half of 8, but 2 is not half of 5. All right, looking at answer choice C, we just determined, well, they're not congruent and they're not similar. So there we go. And we can definitely determine the relationship between the two shapes. Like I can certainly prove right here that they're not equal, and I can certainly prove that they're not congruent. So we definitely know how to determine this, so we can certainly also eliminate that. We definitely know how to figure it out. They just happen to be neither congruent nor similar here. Okay, so this one was neither. All right. Number 6, let's prove whether or not these shapes are similar. So this can be a little tricky. On this shape right here, because we don't have a similarity statement, What side is the longer one? Clearly, this one's longer than this one. Now on this shape over here, I'm going to highlight the longer one green as well. And it looks like the shorter one here is this 25, and here this is a 30. All right, so if I go with green to green, look at what happens with green to green. Was there any change with this? No, not at all. So therefore, we shouldn't expect any change over here, but it looks like the 25 turns into a 30. So let me show y'all what happened here with these rectangles, because this is definitely a no. This is a no. This is definitely a no. When we cross multiply 34 times 30, we're definitely going to get a different answer when we do 34 times 25. So definitely no. And let me draw real quick. Let me just kind of trace this rectangle. Okay. So if it were similar, then everything grows and shrinks proportionally. Okay. So let me show you what happened again with this one. Instead of everything growing proportionally to make this, it looks like what happened was it stretched. Let me see if I can stretch it. There we go. See the stretch? It looks like this stayed the same, but they just stretched this down a little bit to make this 25 a 30 and left this alone. So a stretch down is definitely not proportional. So I'm going to delete that now, and this is a big fat no. This side, the green side, didn't even change. If the blue side got a little bit bigger, then we definitely expect the green side to get a little bit bigger, so this is not proportional. All right, cruising along here. So for number 7, we're just trying to, again, figure out which trapezoids are similar or not similar. For number 7, we're just going through all 4 of these, and we're going to determine similar or not similar. Now here I have a 5, and that's going to match up with the top part of all of these. And the bottom part here is an 8, so that matches up with all of these. All right, cool. So the given ratio that we have that the 5 and the 8 are the blue and the red side. So we're going to go with 5 to 12 for this one, the red with the red. And then here we got blue to blue. Now some of y'all instantly see that this side, the blue side, doubled to be this. So then this 5 should double to be a 10. And since it has a 12, this one we're going to put not similar. Not similar. The bottom doubles, but the top does not. So these are not equal. All right, now let's take a look at this over here. So red to red, the 5 turned into a 20. And the 8 turned into a 24. Some of you might have caught that 5 times 4 gives you 20. So I do times 4. This is times 4. But be careful. 8 times 4. 8 times 4 is 32, y'all. 8 times 4 is 32. So these are not equal. And friendly reminder, you always have your calculator. You've got 5 times 24. So we're looking for a 120. But when we cross multiply 20 times 8, we get a 160. So my 160 on this side does not equal my 120 on this side. So not similar. And I'm just going to copy and paste from this because I can, because I got a computer. But y'all can write not similar for that one now. All right, let's take a look at these bottom two. So again, red matches up. So we've got red to red. So the 5 with a 2.5. And now the 8 with a 4. This one is going to be similar. 5 gets cut in half to be a 2.5. And 8 gets cut in half to be a 4. So this is going to work out. This is going to be similar. And to prove it in that calculator, friendly reminder, when your 5 times 4 is a 20, let's see if I get the same thing over here with 8 times 2.5. Yep, that's also a 20. So since 20 equals 20, we know that these are similar. And last but not least over here, we've got the 5 matching up with a 40. So I've got 5 matching up with 40, red to red. And then 8 down here matches up with a 64. And some of y'all, your math is good. You can see that 5 times 8 is 40. And 8 times 8 is 64. So the red side got 8 times bigger. The blue side got 8 times bigger. So yes, this is similar. These sides form a proportion over here. And 5 times 64, if we do that one in the calculator, it should be the same. 5 times 64. All right, and then we're going to do 8 times 40. Whoops, sorry, clear that. 8 times 40. Blah, sorry, I need to clear that. There we go. There's a 320. So this part of the unit, now that we're in it, I don't care about finding the missing or unknown side. I care about if I give you all the sides, can you now tell me which ones are similar or not? We have one final question here in the video. We're just trying to figure out which statement must be true. And this is a really good review of just like what these, how these like these symbols and letters all look, what this all means in the language of algebra. So for answer choice A, it's saying MO matches with SA. So if I match MO with SA, so far that works. And then let's take, let me get a highlighter out for OE. So OE, does it match with SW? No. OE matches with AW. So we know it's not going to be this one. All right, we already know MO matches with SA. That's blue to blue. And then let's see here, it's saying ME, so we've got this side. Does it match with AW? No. ME matches with SW, and that's not what that says right there, so we're not going to pick that one. All right, now it's just asking us about our angles. It's asking, is angle E the same as angle W? Remember, we have our equal sign, so it's exact. And then it's just reminding us we're dealing with shapes because of that symbol. So is angle E the same as angle W? Yes, they're in corresponding spots, so that's going to be our right answer. And let's just make sure E and S, yeah, E definitely doesn't go with S. They're in totally different spots. We can see the right answer. E is in the last spot right here, and it matches up right here with W in my similarity statement. You're going to flip over now and do some pages in the packet for practice. And that concludes this video. Thank you for watching.